Hey physics fans, today we're talking about TP 5-90. In TP 5-90, the problem statement talks about a mass on an incline oriented 30 degrees. That block on an incline, they ask us to find the magnitude of the acceleration of the block. Well, these are all signs that we're doing some sort of Newton's second law problem. So that's what we're going to do. In my draw step, I just recreate the mass on the incline. They gave us theta, the magnitude of the force, and the mass of the block. And we're going to assume that there's no friction between the block and the incline. Next, we're going to move to our solve step. In our solve step, the first thing we're going to do is draw a free body diagram. In my free body diagram, I'm going to take this mass, I'm going to isolate that mass. After I isolate that mass, I'm going to draw and label my external forces, which is the weight force, the applied force, and the normal force. After I do that, I'm going to create a coordinate axis. My coordinate axis is going to be in the direction of travel of this block. My x direction is going to be oriented in that direction of travel. My y direction is going to be perpendicular to the x direction. Okay, the last thing I'm going to do is label our critical angles, which are 30 degrees here and 30 degrees here. After that, we're going to go ahead and try to solve our problem by summing up the forces in the x direction and in the y direction. Fortunately for us, all we have to do to solve this problem is sum the forces in the x direction because the block is not flying off the incline. Okay, so in summing up all the forces in the x direction, we have to set that equal to the mass times the acceleration of the block. Now let's break down the components of these forces. So the applied force has an x component and a y component. Notice I've labeled all the x components of each force here in pink. So the x component of the applied force is going in the negative x direction, hence the negative sign. The x component of the weight force is going in the positive x direction, positive sign. After I sum these up, I divide by the mass of the block, and I get the acceleration of the block is equal to our algebraic solution here. What we get is negative 6.36 meters per second squared is the acceleration of the block. Now, remember, the problem statement asks us to find the magnitude of that acceleration, and the magnitude of that acceleration is 6 meters per second squared. It is 1 sig fig because that was the least amount of sig figs that we had in the problem statement. So let's do a quick check. Units for acceleration are meters per second squared. Sig figs, least amount of sig figs, like I said before, is 1. And it seems reasonable to be for 6 meters per second squared. That's it for TP 5-90. See you next time. Get a window to the wall. All these problems solved. All these problems solved.